Math 109, hello again. Looking at section 1.3 now. Section 1.3 is all about solving quadratic equations. We have to be very good at solving quadratic equations because that's going to help us do a lot of other things in this course. So there are kind of 5 ways to do it. They don't all work all the time. Some of them are faster or easier than others. But the first way we're going to teach is factoring. That's to me the easiest way, but it's not always possible. So we need something besides factoring. But with factoring, there are 3 kinds of factoring that we need to know how to do. GCF, greatest common factor. Trinomial factoring, I'll show you what that means. AC method, also known as the slip, slide, slip method. 2, the square root method. This is not factoring anymore. This is a different square root method. 3, complete the square. 4, quadratic formula. And 5, with the calculator. You might say, well, why don't I'll just always use the calculator. Well, it's because we sometimes need to be able to give an exact answer. And the calculator, as we've seen, a lot of times it gives you a decimal that has to be rounded off. So to give an exact answer, we have to use these other methods. All right, so we're going to go with fact first. So factoring, GCF. Here's some examples. Let's say you had 3x squared minus 5x equals 0. One way to solve that is by factoring out the GCF. All right, the GCF. That means what can come out of both of these terms. What can be divided out of both of these terms. It's kind of like the anti-distributive property. Distributive property means you multiply something into multiple terms. Factoring means you divide something out of multiple terms. So what can I factor out of 3x squared and 5x? Well, there's not a number because 3 and 5 have no common factors. But the x squared and the x have a common factor. What is it? What can divide out of an x squared and an x? An x can. So what's left when I divide an x out of both of those terms? Well, when I divide an x out of a 3x squared, I'm left with 3x. Minus, when I divide an x out of the 5x, I'm just left with a 5. If we were to distribute the x, we would get x times 3x is 3x squared, and x times negative 5 is negative 5x. We'd be back where we started. All right, so now that we've factored, I need to take an aside here. An aside. If we have, let's say, a times b equals 0. That would be true if a were equal to 0. Then it wouldn't matter what b is. If a was equal to 0, this would be a true statement. Or if b were equal to 0, it wouldn't matter what a is. This would be a true statement. But for these 2 things to multiply to get 0, one of them would need to be 0. Okay, that does not work for any other number but 0 here. It wouldn't be true if I said a times b equals 5. That would not mean that a equals 5 or b equals 5. Because if a was 5, then if b were, let's say, 3, then you'd have 15 equals 5. That wouldn't be true. This only works for 0. So factoring only works when you have everything on one side and a 0 on the other side. Okay, when we have that, then we can say this times this, like say this is a times b equals 0. And this would be true if either a or b equals 0. So if this would be true if either x equals 0 or if 3x minus 5 were equal to 0. So we set both of them equal to 0, the outside part and the inside part, because if this times this equals, and one of them needs to be 0. It has to be. Then we solve for it. Well, this one's already solved. X is 0. Here we add 5 and we divide by 3. And x equals 5/3. I get 2 answers, 0 and 5/3. With quadratic equations, you will always get 2 answers. In fact, whatever the degree is of the polynomial, that's how many answers total you should get, whether they're real and imaginary put together. Let me talk about a little bit more about quadratics and why we get two answers. If I were to throw a ball, and I throw the ball like this, it's going to follow a path, a curved path, and that path is a parabola. And if I wanted to know, well, when does the ball reach this height right here? Well, that happens twice. It happens on the way up and on the way down. And so that's why we get two answers for quadratics. Sometimes we might just get one answer. If I throw the ball just right, it will reach that height only at its apex. Then I just get one answer. So some quadratics could have one answer, but that answer would actually, it's called a double solution, or double root, or a double zero, because you get that answer twice, but you get the same answer. So you still get two answers, it's just you get the same answer twice. Or I might throw the ball in such a way that it never reaches that height. And that's when I get something called imaginary solutions. We'll talk about that later. I still get two of them. All right, that's called GCF factoring. Let me do another example of that. Let's say we have, let's say 15x squared plus 25x equals 5x. Okay? If we need to solve this, then if I want to use factoring, what do I have to have? How does it have to be arranged? I have 0 on one side. So I have to move this 5x to the other side in order for there to be 0 on this side, and that's the only way, remember, that factoring works. So I move my 5x over. These are like terms, so I get 15x squared plus 20x equals 0. And now I say, what can I divide evenly out of a 15x squared and a 20x? Can you guess it? 5x. That's the largest, the greatest common factor between a 15, a 20, and then also the x squared and the x, a 5 and an x. So now what's left when I divide this by 5x? I'm left with 3x plus 4. So then I set this and this both equal to 0. I say 5x equals 0, and I say 3x plus 4 equals 0. Here I would need to divide by 5 to get x by itself. 0 divided by 5 is still 0, so I get x equals 0 there. Here I'm just going to skip through these steps. Subtract 4, divide by 3, you get x equals negative 4/3. 0 and negative 4/3 are my two answers. Alright, that's called GCF factoring. Alright, we also have a factoring called trinomial factoring. Let me see if I can make up a few good trinomial factoring problems. Let's say we have trinomial factoring. Let's say we have x squared plus 3x plus 2 equals 0. This is a very simple one. Let's do x squared minus 8x plus 16. Let's say we had x squared minus 5x minus 24. Let's say we had x squared. Let's say plus x minus 12. Okay. So, trinomial factoring. We are trying to break this trinomial apart into two binomials that if you were to distribute them or FOIL them together, you would end up here. So remember, when you FOIL or double distribute, this times this will give you this. So what two things multiply together to give you x squared? X and x. And then these two numbers will multiply together to get 2. Well, what about the middle term? These last numbers here will end up distributing with the x's and adding together to get the middle term. So not only do these last two numbers have to multiply to get the last number, they have to also add to get the middle number. So you're trying to figure out what multiplies to get 2 and adds to get 3. Would it be a 2 and a 1? 2 times 1 is 2. 2 plus 1 is 3. So it works. Alright. So now the same thing as before. That times that equals 0, which means one of these have to equal 0. So I solve both of them. X equals -2 here, and x equals -1 here. And if x equals -2 or -1, you're going to get a true statement. So -2 and -1 are both solutions. All right, let's try this one. Again, this has got to be x and x to multiply to get x squared. Now we have to come up with two numbers that multiply to get positive 16 and add to get -8. They multiply to get positive 16 and they add to get -8. So these two things, in order to multiply to get positive 16, they have to both be positive or both be negative. Right? A positive times a positive gives you positive, or a negative times a negative gives you a positive. In order to add to get the -8, they're going to both have to be what? They're going to both have to be negative. So, what is it going to be? -4 and -4. -4 times -4 is 16. -4 plus -4 is -8. So I set both of these equal to 0, but notice that they're the same thing. So I'm going to get x minus 4 equals 0, and I'm going to get x equals 4. And I get it twice. This is what's known as that double root, or double 0. 4 is a double solution because it happens twice. That's the kind where I throw the ball and it just does hit that height at the apex. All right, so we're looking at a graph. This one would be where it would cross the x-axis at -1 and -2, whereas this one would be where it would cross. It wouldn't cross. It would touch the x-axis at 4 and bounce. It would just touch the x-axis at 4, not pass through it, but touch it. All right, let's do this one. Again, x and x. See if you can figure out what multiplies to get -24 and adds to get -5. In fact, if you want to pause this video and try these last two problems on your own before we do them together, that'd be a good idea. All right, so what multiplies to get -24 and adds to get -5? Well, let's think. 4 and 6 won't do it. 2 and 12 won't do it. 1 and 24 won't do it. What about 8 and 3? 8 and a 3. But what if they're going to multiply to get -24? One of them's got to be positive and one of them's got to be negative. They got to be opposite signs to get a negative result when they multiply. Which one needs to be positive and negative? Well, if they're going to add to get -5, the bigger one's going to have to be negative. -8 times 3 is -24. -8 plus 3 is -5. Set both of them equal to 0. I'm just going to go fast here. If you set them equal to 0, you're going to get +8 and -3 when you solve them. When you move them over to the other side, you're going to get +8 and -3. So those are my two answers for that one. Okay. Again, what multiplies to get -12? Adds to get +1. How about a 4 and a 3? What kind of a 4 and a 3? Well, if they're going to add to get a +1 and multiply to get a -12, they got to be opposite signs, and the bigger one needs to be positive in order to add to get +1. So what are my answers going to be when I solve these and I move them over to the other side? They're going to be -4 and +3. All right, that's called trinomial factoring. Okay, next we got something called the AC method, or AKA slip, slide, slip. Okay, this is the kind where you have, it's going to be extremely similar to these, but you're going to have a number in front of the x squared. Notice on these last 4 examples, there was no number in front of the x squared. So what if there is a number in front of the x squared? That's what we're going to deal with here. All right, let me find a good example for you. How about 2x squared plus 7x plus 3 equals 0. Alright, the AC method, it's called that because if you call the 2 the A, the 7 the B, and the 3 the C, you take the A and the C, the 2 and the 3, and you multiply them together. You take the 2, the A, and you take it down there with the C, which is 3, and you multiply it. So you get x squared plus 7x plus 6. Alright, notice I don't have the 2 here anymore. This is just kind of a trick for how to do this. There's other tricks for how to do it. If you learned a different way at another time in your schooling history and you're good at it, I don't care. That's fine as long as you can get the right answer. So, but this is a good way to do it as well. So from here, I do it just like I did before. I will say what multiplies to get 6 and adds to get 7. How about a 6 and a 1? Alright, that's why it's called the AC method, but it's also called the slip, slide, slip method because you slip the 2 down there with the 3. Alright, but now, see, that was kind of cheating when we did that. And now we're going to uncheat. We multiplied the 2 to get, with the 3 to get 6, but now we're going, we split the 6 up into a 6 and a 1, and now we're going to undo what we did before. We're going to uncheat. We're going to divide both of these numbers by that same 2 that we multiplied earlier, and that's going to fix it. That's going to fix what the cheating that we did before. It's going to make it be okay. Now, if we can reduce. If we can't reduce, if we still have a number on the bottom, that's when we slip the 2 down there with the 3. Then we slide the 2 back up under here. Slip the 2 with the 3. Slide the 2 back under here. Then if we have a number on the bottom at the end, we slip it back in front of the x. So if we can reduce, though, you should reduce. 6 over reduces. What does it reduce to? So we have x plus 3 because it reduces to 3. But this one doesn't reduce. So I slip that 2 back in front of that x. So 2x plus 1. And now it is factored correctly. And I can continue to solve this by setting this and this both equal to 0. X plus 3 equals 0. 2x plus 1 equals 0. Move the 3, I get x equals negative 3. Subtract the 1, divide the 2, I get x equals negative 1/2. I'm going a little fast here because I know you've had this before. Alright, let me make up another one. How about 3x squared plus 5x minus 8. Alright, if you want to go ahead and try that, you can. Pause the video. Alright, we're going to slip the 3 down there with the negative 8. And when I do that, I get x squared plus 5x minus 24. Then I will break this up into what multiplies to get negative 24, adds to get 5, a positive 8, and a minus 3. Then I slip the 3. I slide the 3 back up under those two numbers, and then I either reduce or I slip the number on bottom back in front of the x. This won't reduce, so I slip the 3 in front of the x and it becomes 3x plus 8. This will reduce, so it becomes x minus 1. And then I solve both of them by setting both equal to 0. On this one I get x equals negative 8/3. On this one I get positive 1. That's the slip, slide, slip method. And that is pretty much all we need for factoring. Let me just say this. If we had had 3x squared minus 8 equals 5x, can we factor that? We can if we rearrange it, right? I would need to move the 5x over here by subtracting 5x from both sides. And I get 3x squared. Make sure you arrange it in the proper order. It needs to be the x squared and x and then the constant. Minus 5x minus 8 equals 0. And now we can factor this kind of like we factored this, except this 5 is negative instead of positive now. So it's going to come out a little bit different with different signs. But we would do it the same way we did this. There is one more kind of factoring that I did forget, and it is called, what's the name of this? It's called difference of squares. A difference of squares is when you have a perfect square here, a perfect square here, and a minus sign between them. Not a plus, but a minus sign. That's why it's called a difference of squares. So when you have a difference of squares, it can always factor as the square root of this plus the square root of this, and then the square root of this minus the square root of this. So that's going to be x plus 3 and x minus 3. So then we solve both of them, we get x equals negative 3 and a positive 3. Which leads us into the next way to solve quadratics besides factoring. And that is, we could have this another way. It's called the square root method. Square root method. The square root method works when you have an x squared term in this equation, but no x term. Only an x squared, but no x. If that's the case, you can get the x by itself by using the square root method. So I'm going to get the x by itself. What am I going to do to get x by itself? I'm going to add 9 to both sides to get rid of that 9. I get x squared equals 9. Then I got to get rid of that squared exponent by doing the opposite of a squared exponent. What is the opposite of a squared exponent? It is a square root. So I take the square root of both sides, and that gets rid of that squared exponent. And I have x equals, whenever you take the square root of both sides, you have to put something in front of the answer. Do you remember what it is? It is plus or minus. So x equals plus or minus 3, because if I have x squared equals 9, that will be true. If x is 3, it'll be true, because 3 squared. But also, if x is negative 3, it'll be true also. So whenever you take the square root of both sides, remember to put plus or minus in front of this result here. Notice we get the same answer both ways. Negative 3, positive 3, a negative 3, and a positive 3. All right. Let's do some more of those. Let's say we had x squared minus 5 equals 0. Move the 5 by adding 5. X squared equals 5. Square root both sides. X equals, this time, 5 doesn't have a perfect square root. I'm just going to leave it as the square root of 5. So plus or minus the square root of 5 is my answer here. That is an exact answer. I could get it as a decimal by taking the square root of 5 in my calculator, and I'd have to round it off. But this is, I can leave it like this and it'd be an exact answer. Let's say we had, give me another good problem here. So we have x squared equals 36. This time we just take the square root of both sides. We don't even have to move anything. X equals what? Plus or minus 6. Let's say we have 3x squared minus 7 equals 0. Add the 7. 3x squared equals 7 divided by 3. X squared equals 7/3. Square root both sides. X equals plus or minus the square root of 7/3. Or you may have to rationalize your denominator here, because you don't want a radical on the bottom. You've probably heard that before. So we do that by, let me do it up here. We can split it up into the square root of 7 of the square root of 3. So we can split up into 2 different square roots. Then to get rid of the radical on the bottom, I multiply it with itself. And whatever I do to the bottom, I do to the top. So that gives me the square root of 21 over the square root of 9. Well, the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is just 3. And this will always be the case. The square root of something times the square root of something just gives you that something. So whatever that is under the radical, when you multiply it with itself, you're going to get that. So this equals the square root of 21 over 3. And don't forget we have a plus or minus in front of it. So this is the same answer as this. If you were to do those in your calculator, you get the same exact decimal. More square root method. Let's say we have x minus 1 squared equals 4. Notice I still have just an x that's squared here. I don't have an extra x term. Okay. One way you can do this is to do x minus 1 times itself and then FOIL it and then add your like terms and then try to factor or something. But the easier way is the square root method. I can get rid of that squared exponent by doing a square root. So I do that on both sides. And I get x minus 1 equals what? What's the square root of 4? 2. But remember, you got to put plus or minus in front of it. So x minus 1 equals plus or minus 2. Then I need to get rid of that minus 1 by adding 1. So x equals, I'm going to put the 1 first. 1 plus or minus 2. Then that can turn into 1 plus 2 and 1 minus 2 as two different answers, which becomes 1 plus 2 is 3 and 1 minus 2 is negative 1. So 3 and negative 1 are my answers. All right, let's do another. Let's say we have find a good one. Let's say we have x plus 3 squared equals 10. Take the square root of both sides. You get rid of that squared exponent. You have x plus 3 equals plus or minus. I can't take the square root of 10. I can't even break it down. So I'm just going to leave it as the square root of 10. Then I subtract 3. And I say x equals, I write the negative 3 first, plus or minus the square root of 10. And you just leave it like that, because we can't do anything else with it. All right, notice the difference here. The difference in these two problems is this number had a perfect square root, whereas this one didn't. So we ended up with just two plain old answers, just good old integer answers here, whereas this one we ended up with kind of a more complicated looking answer. Let me do another one like that. Let's say we had 2x minus 5 squared equals, or let's just try 2x minus 5 squared plus 16 equals 36. What do we do first? We get rid of that 16 by subtracting it. That gives me 2x minus 5 squared equals 20. Then what? Square root both sides. 2x minus 5 equals plus or minus the square root of 20, but the square root of 20 can break down. Let me show you. It can break down to 4 times 5, and the 4 can break down to 2 times 2. So I have a pair of 2's with an extra 5 left over. So it becomes 2 outside and the square root and the 5 on the inside of the square root. Then what? I add 5. I put the 5 first. 2x equals 5 plus or minus 2 root 5. Then I have to divide by 2. And that finishes up my problem. X equals 5 plus or minus 2 root 5 over 2. Another way you may see this answer written is split up with, let me write it over here. You can split it up as 5 over 2 plus or minus 2 root 5 over 2, which then the 2 and the 2 can reduce each other. So you might see it written like this. 5 over 2 plus or minus 2 over 2 is just 1, so it's just root 5. This answer, and this answer are all the same answer. Just a matter of what Math Excel wants you to enter, or if you're on a multiple choice test looking for the correct answer choice. That is pretty much it for the square root method. All right, this next method is called completing the square. I want you to factor each of these. This is kind of an introduction to completing the square. We have to do this in order to understand what we're doing with completing the square. Just factor this. Factor each of these in your minds. Pause the video and go ahead and factor each of those in your minds. You don't even have to write it down. Okay, hopefully you've done that. Now, how does this factor x what? Plus 1 and plus 1. Or we could say x plus 1 squared. What about this one? x plus 2 and x plus 2, or we could say x2 squared. What about this one? X minus 3 and x minus 3, or x minus 3 squared. What about this one? X minus 4 squared. I bet you can even maybe tell, like, what is it about these trinomials that make them factor into a perfect square, into a squared binomial. So let me make the next x squared. Let's say plus 10x plus what? Well, notice each one of these is a perfect square on the end. There's something else though to notice. If you take half of this number and square it, do you get this number? Half of 2 is 1. 1 squared is 1. Half of 4 is 2. 2 squared is 4. Half of 6 is 3. 3 squared is 9. Half of 8 is 4. 4 squared is 16. So now what about this one? Half of 10 is 5. 5 squared is, so what am I going to write here? 25. So how does this factor? X plus 5 squared. You just completed the square by doing that. So let's see if we can do another one. Let's say x squared minus 12x. What am I going to write right there to make that into a perfect square trinomial? Can you get it? Did you say plus 36? Because half of 12 is 6. 6 squared is 36. If you did, you've got the pattern down pat. Now what does that have to do with solving quadratic equations? Let me get us a good complete the square problem here. Let's see here. Let's say we have x squared. Let me change papers because I'm going to need a lot of room. X squared plus 4x minus 21 equals 0. Well, this thing actually we don't have to complete the square because this will factor. It factors as x plus 7, x minus 3. So we know our answers are going to be negative 7 and positive 3. But let's do complete the square just to learn how to do it. Here's how we complete the square. We take the constant and move it to the other side. Say x squared plus 4x equals 21. So we added 21 to both sides. Notice I left some room here. I left some room in order to complete the square. I want to make this side right here into a perfect square trinomial. So what would I need to write right here in order to make it into a perfect square trinomial? Half of 4 is 2. 2 squared is 4. So I'm going to put plus 4 right there. And I can do that as long as I do the same thing to the other side, right? Okay, so now go ahead and factor that. How does it factor? X plus 2 and x plus 2, or we can say x plus 2 squared. And now x plus 2 squared equals what? Equals 25. Okay. Now this problem should look familiar. It looks a lot like the square root method. So now we're going to be able to use the square root method to finish solving the problem. So x plus 2 equals plus or minus 5, subtract 2. X equals negative 2 plus or minus 5, which turns into negative 2 plus 5, and negative 2 minus 5, which turns into, what's negative 2 plus 5? 3, and negative 7, which is what we said before. Okay. Now, completing the square. Let's see, is this one going to be good? If we do plus 9, 13 plus 9 is 22. Yeah, this will be a good one. Let's say we have x squared minus 6x equals 13. We want to complete the square. Let's say we want to solve this by completing the square. Well, what do I write right there in order to complete the square? I say plus half of 6 is 3, squared is 9, so plus 9, and I do the same to the thing to the other side. So that gives me x minus, how does that factor? X minus 3 squared equals 13 plus 9 is 22. Then I take the square root of both sides. I say x minus 3 equals plus or minus the square root of 22. I can't break down the square root of 22. It just breaks down to 2 and 11. So there are no partners there so that we can take something out. So I'll just leave it square root of 22. I add 3. I get x equals, I write the 3 first. 3 plus or minus the square root of 22. So that's how you do complete the square. Now, when should you complete the square? Let me just show you something before we answer that question. When should you use that? When should you use what here? When should you use factoring or complete the square or square root method and all that stuff? Let me show you something before we answer that question. Let's say we had a general quadratic equation. Let's say it is ax squared plus bx plus c equals 0. So now this is any quadratic equation in the world. A, B, or C can be anything, so that every quadratic equation in the world could be represented right here, depending on what A, B, and C are. Okay, let's see if we can solve this by completing the square. This may hurt a little bit. It's going to be pretty complicated, but don't be scared. I'll give you some good news in the end. What do we do first? We move the C, right? We subtract C. Actually, hold on. Let me start over. Ax squared plus bx plus c. We don't want there to be an a. We want it'll be a whole lot easier if I didn't have an a here. So how can I get rid of that a in front of that x squared? I can divide everything by a. So I have x squared plus b over ax plus c over a. Now move this. Subtract c over a from both sides. So I've got x squared plus b over ax equals negative c over a. And now I want to complete the square. How do I complete the square? I take that and I take the square root of it and I square it. I'm not the square root. I take half of it and I square it. I'm going to take half of b over a. I'm going to say b over a divided by 2. Well, to divide fractions, I got to keep change slips. That's b over a times 1 over 2, which is b over 2a. And then I have to square that, remember? So that gives me plus, square this, I get b squared over 4a. That I'm going to add to this side, and I'm going to add to this side, b squared over 4a. Alright, now, how does this factor? We want to figure out what multiplies to get b over 4a and adds to get b over a, and that's going to be b over 2a. b over 2a times b over 2a is b squared over 4a. Sorry, 4a squared. I'm sorry. When I square the b, square the 2, square the a, it should be b squared over, square the b, you get b squared, square the 2, you get 4, square the a, you get a squared. So b squared over 4a squared. So b over 2a times b over 2a is b squared over 4a squared. And b over 2a plus b over 2a is 2b over 2a, which is just b over a. So it factors as x plus b over 2a squared equals, I want to combine this into a single fraction, so I got to get a common denominator. So the way that I can do that is I can multiply this by 4 on the top and the bottom, and also by a on the top and the bottom, so that I'll 4a squared on the bottom. So that gives me negative 4ac over 4a squared plus b squared over 4a squared. Now they have common denominators. I can combine them into a single fraction. When I do, I'm just going to write the b squared before the minus 4ac. So it gives me b squared minus 4ac over 4a squared. Again, don't get scared. I know this is kind of complicated, but just hold on for the ride. Now what do? I'm getting x by itself. I got to square root both sides. So that gives me, I'm going to come up here, that gives me x plus b over 2a equals what? Equals plus or minus the square root of b squared minus 4ac over, what's the square root of 4a squared? It's 2a. The square root of 4 is 2, the square root of a squared is 2a. Is a, so 2a. Now to get x by itself, what do? I subtract b over 2a on both sides, and I get x equals a negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And I want to combine these into a single fraction. Luckily, they already have common denominator. So now x equals what? Watch this stuff. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Bada bing, bada bang, bada booyah. What's that? The quadratic dadgum formula. Yay. We just derived the quadratic formula by completing the square. That's awesome. Whenever you do that, you just drop the pen. All right. Now this quadratic formula, by the way, is that now, notice, I started with any quadratic equation in the world. Anything. Doesn't matter what A, B, and C are. I now have a formula that will solve any quadratic in the world. All I got to do is plug the numbers in for any quadratic, and I have the answers for x. So then when should we use completing the square? Never. You never have to use completing the square. The only reason we taught completing the square was to show you how you come up with the quadratic formula, how historically this was discovered. Okay, so we need to show you how to use the quadratic formula, how to, some examples of how it works, and then we'll talk about when should you use what. Negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. Sing that song to yourself 10 times, and you will remember the quadratic formula forever. All right, now let's use the quadratic formula. Let's say we had x squared plus 4x equals 21. We've already done this one, but we're going to learn how to solve the same thing just using the quadratic formula. Well, to do the quadratic formula, you remember it was ax squared plus bx plus c equals 0. So I first need to arrange my quadratic equation like this, which means I need to move my 21 over here. So x squared plus 4x minus 21 equals 0. Now I can know that now that I've got it arranged, my a is whatever's in front of the x squared, which is 1. My b is whatever's in front of the x, which is 4. And my c is whatever the constant is, which is negative 20. And now I plug the 1, the 4, and the negative 21 in for a, b, and c, respectively. So negative b, that's negative 4, plus or minus the square root of 4 squared minus 4 times 1 times negative 21 over 2 times 1. That's negative 4 plus or minus the square root of 16 plus 4 times 1 times 21. That's going to be 84 over 2, which is negative 4 plus or minus the square root of 6 and 4 is 10, carry 1, 8 and 1 is 9, plus 1 is 10, so 100 over 2. That's negative 4 plus or minus, what is the square root of 100? 10 over 2, which is going to be negative 4 plus 10 over 2, and negative 4 minus 10 over 2, which is going to be negative 4 plus 10 is 6 over 2, and negative 4 minus 10 is negative 14 over 2, which finally turns into our final answers of 3 and -7. 3 and -7. So that's the same answers we came up with the other way by either factoring or the completing the square. 3 and -7. All right. So let's do some more of that. How about this one? 3x squared minus 5x plus 1 equals 0. Why don't you go ahead and try to do the quadratic formula. Pause the video and try it yourself before we do it together. All right, here we go. So there's your A, there's B, there's your C. So it's -5 plus or minus the square root of -5 squared minus 4 times 3 times 1 over 2 times 3, which is -5 means it's going to be +5, plus or minus the square root of -5 squared is +25, minus 4 times 3 times 1 is 12 over 6, which is 5, plus or minus the square root of 25 minus 12 is 13 over 6. And you know what? We're done, because we can't break down the square root of 13. There's nothing else we can do to simplify this. You might see it written as 5, 6 plus or minus the square root of 13 over 6. So we could split it up, but that's the same answer. It shouldn't matter which one you put in. Alrighty. So all right, let's just say we ended up with this kind of an answer. If we end up with this kind of an answer, we're going to have to reduce it sometimes. Like we couldn't reduce this one. There was nothing we could do to reduce it. But there's something we can do to reduce some of these. When you reduce, you have to be able to divide every term by the same number. You cannot touch what's inside the square root. But maybe if you break the square root down and pull something out of it to the outside, then you can do something with whatever's on the outside of it. So like the square root of 20 breaks down to, we saw earlier, 4 times 5, 2 times 2, so I got a pair of 2's and an extra 5, so 4 plus or minus 2 times the square root of 5 over 6. Now, all of these terms can divide by 2. So that gives me 2 plus or minus, well, that's just going to be 1 times the square root of 5 over 3. So we have to reduce our answers sometimes like that. So when do we use what? I like to use factoring just whenever I can because it is so simple and quick. Like if I have x squared minus x minus 21, or maybe it was plus 4x, I don't remember. I can factor that so fast and know that my answers are -7 and +3. That's just so much faster and easier to me than the quadratic formula. So if I can factor, then I will do that. I will factor. If I have, how do I tell real quick? I can tell if I can factor quickly by, say, is there anything that multiply to get 21, and multiply to get -21, and add to get 4, and I can think of that 7 and 3 quickly. If you can't multiply to get this number and add to get this number, then you can't factor. Something like that. So then that's when I would just go straight to the quadratic formula. If I can't factor this trinomial, I'm going to do the quadratic formula. When do I use the square root method? I've kind of already told you that you use the square root method when you have an x squared term and nothing else. Or even if you have this. If you have this squared expression and no x term. If you have an x squared but no x, or if you have a squared expression and no x, then you can use the square root method. Otherwise, you can use the quadratic formula you can always use quadratic formula anytime. If you're good at it, feel free. And if you're better at the quadratic formula than you are factoring, go ahead and do the quadratic formula every time. It works all the time. That's the advantage of the quadratic formula. Here is a problem that you may encounter on your homework. Okay. A word problem from section. From each corner of a square piece of sheet metal, remove a square of side 9 centimeters. So we got a square. Here you can see it right here. Turn up the edges to form an open box. If the box is to hold 144 cubic centimeters, what should be the dimensions of the piece of sheet metal? All right. So we have this piece of sheet metal. It should be a square. I kind of didn't draw a square, but you're going to cut out 9 centimeters from each side, from each corner. And then you're going to, after these corners out, you're going to fold this up, fold that up, fold that up, fold that up, and it's going to make a box. It wants the box to hold 144 cubic meters, and it wants to know what needs to be the original size, the original dimensions of that square piece of sheet metal. So the length and the width of the sheet metal. And since this is a square, they can both be just called X, because square means both of these are the same length, the length and the width. So the volume is 144 cubic centimeters. What is the formula for the volume of a box? Well, it's going to be length times width times height, or you could call it depth. LWH or LWD. So 144 is my volume, and that's going to equal the length of this box. What is the length of this box going to be? It started out X, but remember we took away 9 on each side. So what is it? X minus 18. Well, what's the width? Again, we started out with X, but we took away 9 on each side of the width as well. So again, X minus 18. And what is the depth of the box? Well, when we turn up this side and we're staring down into the box, what is the depth of the box? It is exactly the 9 centimeters that we cut out and turned up. So the depth or height is 9. And now I want to solve this. I would advise you first to get rid of that 9 by dividing by 9. 144 divided by 9. 9 goes into 14 one time. That's going to be 16. And I'm going to write this as X minus 18 squared. It's a quadratic equation. What would I do here? I would do the square root method. Take the square root of both sides. Minus 18 equals plus or minus 4. Add 18 to both sides. 18 plus or minus 4 equals X. So 18 plus 4 and 18 minus 4. So that's going to be 20. No, sorry, it's going to be 22 and 14. So 22 and 14 are my answers, but you always got to look back to see if your answer makes sense in the original problem. Originally, we said that we got a square piece of sheet metal. We're taking 9 centimeters from each corner. If my length or width is 14, and I take away 9 and 9, I'm taking 18 away from the 14, which means I can do it. That's just not possible. I can't take 14 inches away from 18 inches when I'm dealing with the real sheet metal. So 14 is, even though it's a solution on paper, it is not a solution to the original context of the word problem. 22 is the only solution to that word problem. Hopefully you're now going to be able to do section 1.3. And let me just say this one more thing. If you get in a panic, if you get stuck, with these quadratic equations, you could try to do it in your calculator with the graphing feature, like I showed you on 1.2. As long as you get the right answer, I'm not really concerned how you got it. Neither is Math Excel. So I'm not even going to know how you did it. So I'm good with you doing the calculator, but like I said before, is that sometimes if MathXL wants an exact answer, then if the calculator, if the answers are just like 3 and 5, the calculator can give you that. But if the answer is something like 2.5932 blah blah blah, which turns out to be like 3 plus the square root of 2 or something. Of course, that's not true, but if it did turn out to be that way, you would have to enter this kind of answer, not this kind of answer. So the calculator wouldn't help you. You'd have to do something by hand to end up with like this, an exact answer. All right, good luck on your homework on 1.3, and I'll see you next time for 1.4.